What is nuclear power? Nuclear power is the use of nuclear reactions that release nuclear energy to generate heat, which most frequently is then used in steam turbines to produce electricity in a nuclear power plant. The first commercial nuclear power stations started operation in the 1950s. Nuclear energy now provides about 10% of the world's electricity from about 440 power reactors. Nuclear is the world's second largest source of low-carbon power, 29% of the total in 2017. Over 50 countries utilize nuclear energy in about 220 research reactors. In addition to research, these reactors are used for the production of medical and industrial isotopes, as well as for training. How nuclear power works. Nuclear power can be obtained from nuclear fission, nuclear decay, and nuclear fusion. All nuclear power plants use nuclear fission, and most nuclear power plants use uranium atoms. When uranium atom undergoes fission, the newly formed half of lighter atom, called the direct products of fission, iodine, cesium, strontium, cobalt, or any some 30 other elements, are generally unstable isotopes. Unstable isotopes, called radioisotopes, become stable by spontaneously ejecting subatomic particles, alpha particles, beta particles, and neutrons, or high-energy radiation, gamma rays, or both. This process produces energy. These neutrons continue to collide with other uranium atoms, and the process repeats itself over and over again. This process is called a nuclear chain reaction. This reaction is controlled in nuclear power plant reactors to produce a desired amount of heat. The hazards of nuclear power. Number 1. Radioactivity. Radioactivity is measured in curies in old days, now changed to becquerels in the SI standard. 1 gram pure 226 radium gives off 1 curie per second, approximate to 37 billion spontaneous disintegrations into particles and radiation. Indirect product is any material in and around the reactor that is converted to radioisotopes by absorbing neutrons from the fission process. Radioactive waste are direct and indirect products of fission. Radioactive fallout from nuclear explosion also consists of these direct and indirect products. Number 2. Biological effects. Radioactive emissions can penetrate biological tissue. The emissions leave no visible mark, can't be felt, but capable of dislodging electrons from molecules or atoms that strip. These leave ions behind, and therefore the emissions are called ionizing radiation. In high dose, radiation may cause enough damage to prevent cell division. Thus, in medical applications, radiation can be focused on a cancerous tumor to destroy it, called radiotherapy. However, if the whole body is exposed to such level of radiation, over 1 sievert considered high dose, a generalized blockage of cell division occurs that prevents normal replacement of blood, skin, and other tissue and causes radiation sickness. Radiation sickness causes death in a few days or months after exposure. High exposure may totally destroy cells, causing immediate death. In lower dosage, radiation may damage DNA. Cells with damaged DNA may then begin dividing and growing out of control, forming malignant tumors or leukemia. If the damaged DNA is in an egg or sperm cell, birth defects occurs in offspring. Vomiting, purpura, or bleeding under skin is one of the symptoms of acute radiation sickness. The heavily exposed survivors experience fever, nausea, vomiting, lack of appetite, bloody diarrhea, epilation, purpura, sores in their throat or mouth, and decay and ulceration of the gums about the teeth. The time of onset of these symptoms depends on the exposure level. Number 3. Radioactive leaks. Half-life is the rate of death. Half of the starting amount will undergo radioactive decay. In the next equal period of time, half of the remainder decays. The half-life of an isotope is always the same, regardless of the starting amount. The half-life for various isotopes range from a fraction of seconds to many thousands of years. Uranium fission results in a heterogeneous mixture of radioisotopes. Some of these material can be recovered and recycled for use as nuclear fuel, in particular the remaining uranium-235 and plutonium-239. Plutonium-239 has been created by the neutron bombardment of uranium-238. Number 4. Disposal of radioactive waste. Current problems of nuclear waste disposal is twofold. Short-term containment is used to allow the radioactive decay of short-lived isotopes. In 10 years, fission waste lost more than 97% of their radioactivity. Waste can be handled much more easily and safely after this loss occurs. Long-term containment is used to provide protection from the long-lived isotopes. EPA recommends a 10,000-year minimum, and the National Research Council opts for 100,000 years. United States government's standards require isolation for 20 half-life. Plutonium has a half-life of 24,000 years. In short-term containment, spent fuel stored in deep swimming pool-like tanks on nuclear power plant site. The water in these tanks dissipates waste heat and acts as shower. After a few years of decay, the spent fuel is moved to dry case, a safe space. Spent fuel are air-cooled in case. The waste from world's commercial reactors are accumulating at 10,000 tons per year. Because of nuclear bombardment of the reactor walls, all nuclear power plants will eventually add to the stockpile of radioactive waste. Scientists estimate that dismantling a decommissioned power plant will generate more nuclear waste than the plant produced during its active life. Ocean dumping of radioactive waste. Until 1970, the United States, Britain, France, and Japan disposed of radioactive waste in the ocean. Soviet Union dumped active nuclear reactors, 7 loaded with nuclear fuel, in the Kara Sea off the eastern coast of Novaya Zemlya Island, and millions of liters of liquid waste in the nearby Barents Seas. 2 other reactors were sunk in the Sea of Japan. Altogether, the former Soviet Union dumped 2.5 million curies of radioactive waste into the ocean, more than twice the amount that 12 other nuclear nations have reported dumping over the past 45 years.